In this session, we're going to look at exploring and analyzing some data using both the graphs and displays that we learned about last week and the new material from Chapter 3 from this week. The data set that we're going to look at is in our StatCrunch class group. It's called Low Birth Weight. So feel free to pull it up and follow along as we go. Here's the description of the data set. And this is about low birth weight babies and some of the factors that might contribute to a baby being low birth weight. So what we're going to look at is one particular relationship that we could investigate. The one that we're going to investigate today is whether there's a difference in birth weights for babies whose mothers smoked versus babies whose mothers didn't smoke. And in our data over here, we have the actual birth weights of these babies in grams. And then we have information about the smoking status of the mother. So we're going to use those two variables together to investigate this question. In general, what we're going to do is look at the birth weights of the babies, and we're just going to group those by the mother's smoker status. So we're going to look at different features of the data of the birth weights when we've got the babies divided up into two groups, whether their mother was a smoker or not. We're going to look at the similarities and differences between those two sets of birth weights. So first, we're just going to explore the data that we have. We're going to look at lots of different graphs and displays. We're going to look at the descriptive statistics and see what that might have to tell us. We're going to start with creating graphs, and we want to do ones that are appropriate for quantitative variables and appropriate for this situation. We could do a frequency distribution table. As we found out last week, when we do a frequency distribution table in StatCrunch, it creates the classes for us. We don't have any choice about that, but we'll still look at those. We'll do histograms. We can do stem and leaf plots. A dot plot is something that won't work well in this situation because we have so many different values for our birth weights. So we're not going to do a dot plot. A scatter plot also won't work in this situation because we only have one quantitative variable. We don't have two quantitative variables. And two extra items that are new this week are a summary statistics display. That's going to give us these descriptive statistics down here, which are very important when you're looking at a quantitative variable. And the other new thing from this week is a box plot. This is another graph that's only appropriate for quantitative variables, and it can also be very helpful in showing you the differences between two sets of data. So we'll look at those two things. When we look at our descriptive statistics, we're going to look at this whole list of values for the birth weights of the babies. So let's get started with the frequency distribution tables. So I'm using birth weight as my column, and I'm going to group this by smoker so that we get two different frequency tables. And of course it asks if I want to turn on binning for the birth weight, and I do. So here are our two frequency tables. And one thing that I would notice right away about the difference between these two is that for the smoker equals yes group, there's one baby that had a birth weight of less than 1,000 grams. In this group, there aren't any that had a birth weight that low. Another difference we might notice between these two tables is that in the non-smokers group, the highest frequency class was the 3,000 to 3,999 grams. That had 49% of the babies were that weight. In the smokers group, the highest frequency class was 2,000 to 2,999, and that had 51%. So that's a major difference when we have almost 50% of these babies with much higher weights than the highest class for these babies. So that's one thing I would notice looking at these two tables. And one other thing I want to mention about looking at these two tables is that for the most part, I'm looking at the relative frequencies, because if you notice the counts between the two groups, the non-smokers had 115 total, and the smokers only had 74. Since the totals are quite a bit different, then I don't really want to look at the actual frequencies. I want to look at the relative frequencies if I'm trying to compare these two. The next thing I'm going to look at is the histograms. And actually, before I do the group by, I'm going to look at the histogram for all of the babies, just to get an idea of what that looks like overall. So here's the histogram for the birth weights of all of the babies. One thing I can see here is that the highest frequency class is from 3,000 to 3,499. And this is an important thing to notice when you're looking at histograms, is what the class widths are. Notice this class width is different than what we had in our frequency table, because these class widths were 1,000, and the histogram it created here, the class width is only 500. Now, if I wanted to make it the same as I had in my frequency tables, I could go back and change that. But for right now, I'm going to leave it that way. But the other thing I am going to go back and change is I'm going to change this to a relative frequency instead of a frequency. That way it'll be easier to compare with my other two graphs that I'm going to create. So now I'm going to create the histograms for the two different groups. I'm going to do this twice so that I can see them both side by side, but I want to have them set up the same way. For both of them, I'm going to do the relative frequencies, and both of them I'm going to tell StatCrunch to start the classes at weight 0. That way they'll both look similar. Now I have my two histograms. They're both starting as 0, so they both have the same scale along the horizontal axis. Another thing that I noticed looking at these two is that on the vertical axis, this one only goes up to 0.25. This one goes up to 0.3. So I'm going to squeeze this one down a little bit so that the scales are about the same. That'll make it easier to compare the two. And then I can do the same thing with this one. So now my scales match on my three graphs. Now what I see right away looking at the non-smokers versus the smokers is that the distributions have different shapes. This one has kind of a long tail on this end. It's gradually going down towards the left end. And the highest frequency class is here between 3,000 and 3,499. I'd say that most of the data for this is between 3,000 and 4,000. That matches what we saw in the frequency table over here. And for the smokers, the highest frequency class is between 2,000 and 2,499. And that's much higher than the highest frequency class for this group. So that's a major difference between these two. Looking at this, you could say in general that it looks like the smokers' babies have much lower birth weights than the non-smokers' babies. And if we compare that to the histogram for all of the babies together, in this histogram also the highest frequency class was between 3,000 and 3,499. But in this one there was much more even distribution between the 2,000 and the 4,000. It's kind of interesting that this was the babies overall, and when we split it up into the two groups, the smokers got the lower birth weight babies and the non-smokers got the higher birth weight babies out of that whole group where those were centered around. So that would be a really interesting thing to notice about what happened when we split this up into two groups. The other thing I would notice that's a major difference between these two, the values on the left and the right ends of the graph. In this one, we have at least some babies that were at a much higher weight, between 4,500 and 4,999 grams. This one, there aren't any babies in that class because it doesn't even show that class on the end of the graph. And this one, if we look at the class below that, so starting at 4,000, this one had quite a few. This one had very few. And this one also had some in this really low class below 1,000 grams. So those are just some of the types of things that you could notice looking at a graph like this. One other thing that's important in this one, if we go back and look at the description, that a low birth weight baby is considered to be one that weighs less than 2,500 grams. So thinking about that, if we look at these two graphs, the less than 2,500 grams is the highest frequency class for the smokers, is under 2,500 down to 2,000, and then after that. So the smokers actually have quite a few low birth weight babies, where for the non-smokers, the total of these three classes that are under 2,500 grams isn't nearly as much. One of the things that is new for us this week in Chapter 3 is talking about the center of the data, which is talking about the mean, median, and mode. And that's one of the things you can also do with a histogram. You can have StatCrunch put markers for where the mean and the median are. So I'm going to go back to this, and under markers I'm going to check both the mean and the median. So it will mark those for me. So now I can see on the graph where the center of the data is. And for both of these, the mean and median are very close together. This one, they're so close together that you can't even see the two different markers. They're both there, but you can only really see the green one. In this one, they are also very close together. But you can also see the difference between the two. For the non-smokers, both the mean and the median are just over 3,000. And for the non-smokers, the mean and the median are both at about 2,800. So that's a major difference between these two, where the center of the data would be. The nice thing about having it mark this on the graph is that sometimes just looking at the histogram, it's pretty hard to tell where the center of the data would tend to be. We talked about the fact that this is the highest frequency class for the smokers, is between 2,000 and 2,499, but that's not where the center of our data turned out to be. And that's because we've got these other classes over here that are pulling that mean and median up this direction. In this one, the mean and the median do both fall in that highest frequency class, but notice that they're over towards the left end of it, because again, we've got some data over here that's pulling both of those to the left a little bit. In general, when you're analyzing quantitative data, if you're doing something like writing a report, you definitely want to talk about the mean and the median. Those measures of center are really important for quantitative data. So you might want to do something like this, where the mean and the median are both shown on the histogram. You also want to specifically mention those in the written part of the report. So you would want to say specifically what the mean is for both groups and specifically what the median is for both groups. Now let's look at stem and leaf plots for these. Again, the nice thing about stem and leaf plots is that they give us an idea of the distribution shape, like a histogram would. They also give us more idea what the actual data is. With the histogram, we're limited to just how many things are in each class, and with this we can get a better idea what the actual data is. On these stem and leaf plots, the leaf unit is 100. That means that we've got the thousands digit over here as the stem, and so these are rounding things to the nearest 100 grams. So for example, in this second stem right here, this value in the data would be 1,100, but that's rounded to the nearest 100. Our highest data value, the closest that we know from this, is that it's 4,200. But this gives us a better idea of what those actual minimum and maximum values would be. For example, in this one, this means that that baby that was under 1,000 grams was around 700 grams, and that our highest weight baby was 4,200 grams. And in this one, it looks like the lowest weight baby was around 1,000 grams, and the highest was around 5,000 grams. So this gives us a little bit better idea of what those actual numbers are. And in both of these, it used split stems. So it's giving us the same classes as we had in the histograms. They're going with a class width of 500. So for example, this stem goes from 2,000 up to 2,499. And this one goes from 2,500 up to 2,999. The next thing we're going to look at is the summary statistics. And this again goes back to these descriptive statistics that we've been talking about this week. So we want to look at all of these items. The only one that we're not going to look at for this is the mode. It's a measure of center, but for this big a data set where we've got so many different values, the mode isn't going to be very useful. So we're not going to look at that. But all of these other items we're going to look at in our descriptive statistics. And in StatCrunch, this is called summary stats. You can look at these for the entire sample. Sometimes it's interesting to compare that to the ones for the groups. So I'm going to do one where I don't use the group by. And in this, I'm going to pick out specific statistics I want it to show me. It will automatically give me this list that has some things in it that I don't really care about, like the variance and the standard error, and it is leaving out some of the things I do want to see. So I'm going to pick specific ones from this. So I'm looking at my list of descriptive statistics over here. I want the N, which is just the number in that group, and I want the mean. I don't want the variance. I do want the standard deviation. I want the median, the range, the min, the max, the Q1, the Q3. That will give me the whole 5-number summary. And another thing I want is the IQR. And I also want the coefficient of variation. So those are the things I specifically want to see out of this. So those are my statistics for the entire group of babies. Now I'm going to go back and do the same thing and use the group by, picking out the same statistics for this one. So now I have the ones for the whole group up here, and then I have them grouped by non-smokers and smokers down here. So some interesting things I see looking at the two different groups are, if I'm looking at the center of the data, that means I'm looking at the mean and the median. For both of those are much higher for the non-smokers babies than they are for the smokers babies. That would be something to make note of. And again, if you're writing a report, you could show this table of statistics, but you also would want to specifically mention the mean and the median for both groups in writing in the written part of the report. Then if I'm looking at the variation or the dispersion, that's where I'm looking at the standard deviation, the range, and the coefficient of variation. And I can also look at the IQR for that. So with those, I'm noticing that for the non-smokers, we've got a higher standard deviation, a bigger range, the IQR is bigger, and the coefficient of variation is just a little bit bigger, not by very much. So what that tells me in general is that the non-smokers' babies' birth weights are more spread out, have more variation than there are for the smokers' babies. If we go back and look at the histograms, we can see why that's the case. It was because the smokers had this one class that had a lot of the babies in it. So it had a lot of its data grouped into just one class. whereas the non-smokers had more different classes that had more data in them. So these ones were a little bit more spread out, and they were also a little bit more varied, and these ones were more grouped in one class. So that would be one reason that the standard deviation would be higher. But the other thing, when we're looking at the standard deviation, we also want to look at the coefficient of variation, because this gives us an idea of how much variation there is related to the mean. And for the non-smokers, since the mean was lower, that also helps to make the standard deviation a little bit less. When we look at the coefficient of variation, this takes that into account. The coefficient of variation for the non-smokers isn't that much higher than it is for the smokers. So this would tell us that maybe there isn't that much difference in the variation. We do see a fairly big difference in the range though also, which just means that the non-smokers' babies are more spread out between the min and the max. That goes from 1,021 up to 4,990, and for the smokers it goes from 709 up to 4,238. Now we can look at the min, the max, and the Q1 and the Q3 here with specific values, but we're also going to look at those specifically in the box plot. The box plot is going to show us those better than what we can really tell in the summary statistics. Let's do that next. Let's look at the box plots. And for this, it will automatically show you both box plots on the same graph. I'm going to start out, I'm going to tell it to draw the boxes horizontally just because that fits better with the other kinds of graphs that we do. I'm going to uncheck this box where it says use fences to identify outliers. Okay, so here are my box plots. This is a really nice graph to do for quantitative data. It's not one of the ones we talked about last week because we didn't have the information about the quartiles last week. But looking at this graph, we can see where the two ends of the data are for each of the two different groups. We can see right away that the majority of the non-smokers' babies are higher weight than the majority of the smokers' babies. Another thing we can see from this is another idea about the distribution shape. This box plot down here looks very symmetrical. The median, which is the line in the middle of the box, is almost exactly in the middle of the box. The whiskers on either side are close to being the same length. So this is pretty symmetric. This one, on the other hand, isn't. We see that the median is more towards the left side of the box. The left whisker is longer than the whisker on the right side. So this tells us that we don't have nearly as symmetric distribution for the smokers as we do for the non-smokers. But this also points out the difference in the medians. Here's the median for the non-smokers, here's the median for the smokers. Now another thing we can do with box plots is we can look for outliers or extreme values. And this measures them in a little different way than some other things that we talk about. But to do this on the graph, we have to go back and tell it to use fences to identify outliers. This gives us a little bit different picture, but it marks the ones that it would consider outliers based on the IQR. So when we do that, this gives us just one outlier, and that would be the low birth weight baby for the smokers. That was only about 700 grams. So that one, based on the IQR, would be considered an outlier. The non-smokers didn't have any outliers in their group. And one other thing with the box plots, when we looked at the IQR for the two different groups, notice the IQR for the non-smokers was much higher than it was for the smokers. And that, when you're looking at the box plot, that's the width of the box. So you can see that in the box plots that the non-smoker's box is much wider than the smoker's box. And that box in the box plots tells us where 50% of the data is. So this would be 50% of the baby's weights in this one are between the Q1 and the Q3. So between 2,495 and 3,629. So they all had weights between those two. The fact that this is a wider box tells us that this data is a little bit more spread out than this data. Okay, so now that we have all of this information, what we want to do is look at analyzing it. And we've talked about a lot of these important features already, but these are the types of things that you want to look for when you're trying to analyze data. So we look for things like the classes with the highest and lowest frequencies. We talked about that when we looked at our histograms and the frequency tables. You want to look at the center of the data. Again, that's the mean and the median. Look at the variation or the dispersion in the data. Those were things like the standard deviation, the range, the IQR, and the coefficient of variation. We looked at outliers and extreme values. One thing we didn't talk about was gaps in the data. If we go back and look at the histograms, we really didn't see any gaps in this data. A gap would be, for example, if we had a really low birth weight baby over here that was in this class, and then a gap between that bar. So if we had one class that didn't have anything in it, and then a class above or below that that did have something, that would be considered a gap. But that's not something that we saw in this data. Another thing we talked about was the distribution shape, where this one was actually kind of close to being symmetric. We looked at the histograms and we looked at the box plots for that. This one is kind of hard to tell what you would call that. It was a little bit more obvious with the box plots. So this one looks more symmetric. This one looks like it might be skewed to the left a little bit because we have this outlier over here and because our whisker on this side was longer. And then the main thing, if you're trying to compare data for two different groups, is to look for similarities and differences between the groups. We talked about several different things that were different about the two groups. We didn't talk too much about the similarities because we didn't find that many of those. One similarity would be that the means and the medians were both very close together for both groups. So all of these things are what I would call important features in the data. When I ask you to analyze your data for the tigers, since you'll be looking at quantitative variables, these are the kinds of things I'll be asking you to look for. And then another thing that you want to think about is anything that really stands out about the data. So in this data, what really stood out to me was the difference in where the weights were for the smokers' babies versus the non-smokers' babies. So the fact that the smokers' babies had this really high bar that was so much lower than the highest frequency bar for the non-smokers. That was one thing that really stood out. And the fact that this highest frequency bar for the smokers would be ones who are considered low birth weight. And then you also want to look for unusual features. Those would be things like major outliers, really extreme values, big gaps, situations where you have two distinct groups that show up on a histogram, something like that. And then when we talk about looking for stories in the data, the idea behind that is, what is this really telling us? What is it saying about the smokers' babies versus the non-smokers' babies?